Hello and welcome to another episode of the Geotechnical Engineering Podcast, a podcast focused on helping geotechnical engineers stay up to date with technical trends in the field. I'm your host, Jared Green, and I've practiced as a geotechnical engineer for over 17 and a half years. And in addition to practicing engineering, I enjoy mentoring young engineers and first-generation college students. I focus on helping to increase the number of pre-college students that are interested in STEAM majors and fields. By STEAM, I mean science, technology, engineering, art, and mathematics. In this episode of the Geotechnical Engineering Podcast, I'll be talking to Andrew Burns, the Vice President of Engineering and Estimating for Underpinning Foundation Skanska. He's also known to many by just the name Andy. We will be talking about his career and how he worked his way up from office engineer to vice president, and he also shares some very interesting thoughts about deep foundation elements in SOE design, supportive excavation. Andrew Burns graduated from City College of New York in 1996 with a Bachelor of Engineering and Civil Engineering. In his final year there, he met the late Stanley Merjon of Underpinning Foundation. He went to work for Underpinning upon graduation. He spent 10 years there, working his way up from office engineer for what is now the Hard Rock Cafe at Times Square, through superintendent on numerous driven pile jobs, and on to project manager for the piles at the JFK Air Train. Later, as was the trend in the New York City deep foundation construction market, Andrew became involved on mostly drilled foundations, including drilled shafts, caissons, and micropiles, and one of the first secant walls ever constructed in New York City for the New York City Transit escalator from the Lexington Avenue IRT to the E line at 53rd Street and Lexington Avenue. He has also worked as a project manager for Spearn, Preston, and Burroughs, chief engineer and chief estimator for Intercoastal Foundations Insuring, as well as drilling operations manager and chief engineer for Basilico. He believes strongly that contractor design of deep foundation elements and supportive excavation systems assures the greatest economy and the highest degree of quality control. Andrew is a member of the Moles. He has previously presented for the ADSC, the DFI, and ASCE. He formerly served as the president of the ADSC Northeast chapter and on the external advisory board for the civil engineering program at SUNY Stony Brook. Andrew has been happily married for 30 years and is the proud father of Maggie, 27, and Jack, 23, and he is an amateur musician and avid sailor. And with that, let's jump right into our conversation with Andy Burns. Andy, welcome to the Geotechnical Engineering Podcast. We're honored to have you. How are you feeling, man?
I'm feeling very good today, and thanks for inviting me into your GeoPod.
Excellent. Glad to have you here, man. We gave an introduction for you. We read your bio earlier in the show, but if we had to ask in your own words, can you tell our listeners a little bit more about yourself, your career journey, and then also what does a daily routine look like for you at Underpinning Foundation Skanska?
Yeah, so I'm working from home today in the COVID era, and I have the windows open. So if there's noise in the background, just let me know. But
okay, no, we're good.
Yeah. So I'm very proud to be a civil engineer, and I think even more proud to call myself a geotech. And I'm very honored to be here, to think that anybody would want to hear what I have to say when I think about, the people in this field that I worked with and that I respect, and the things that they've built. And so as I, reach the latter part of my career, it's really a matter of pride to be part of this whole thing. And for that, I appreciate what you're doing here.
Awesome.
On the podcast. So as far as what I do, I'm really very, very fortunate. I have the job, in fact, the very job title that I first wanted over 20 years ago, and that is Vice President of Engineering and Estimating for Underpinning Foundation Skanska. The guy who had that title 25 years ago was the first my first real idol in this business, first guy that I looked up to and said, I want to be Eddie J. McNamara, vice president, et cetera, you know? So,
Wow.
and so that's really meaningful to me. I'm very thankful for that. But for people who don't know, Skanska is one of the largest contractors in the world. And especially when you consider what we call self-performance of work, right? Rather than just subcontracting out work to other people to do it. Underpinning Foundation is a subsidiary of Skanska that is specializes in geotechnical construction. And it's been around since 1897, which makes it one of the oldest contractors in continuous service in the United States. Wow. Here's a fun fact. The founder of the company is a guy, Jules Brichot, who is actually credited 1 year earlier, 1896, with patenting the use of the term and the process of what we now refer to as conventional underpinning. So he got his patent in 1896, and the next year he opened a company called Underpinning Foundation. And so that's how we got here. But day to day, it really works like this. I have a chief engineer and I have a chief estimator, and they report directly to me. Each one of them manages their own staff. But the great thing about working for a specialty contractor is that really everyone in the company is called upon to understand a good bit of everything we do, right? So, the engineers need to understand how the contracts are managed, or the financial people need to understand how we go out and pursue new work. The operations people need to have a good grip on the engineering, right? And the estimators need to know how to get stuff built in the real world, right? And every other combination. So I have a really good team of people that work for me, and nothing gets done without them, right? So that's sort of the day-to-day thing.
Wow, and I gotta imagine that a lot of what you just said is that's stuff that you didn't really learn in school, right?
No, they don't teach you that stuff. Going back to my school days, you and I have spoken about this before. So, my background may be a little different than a lot of other engineers. I got my first Beatle record when I was 5. By my 6th birthday, I had every Beatle record. I knew the words to every song, and all I wanted to be, in my middle school years was a rock star, lead guitar player, singer songwriter. And but as I got a little older, a little more mature, to think about college and stuff, I turned to classical music, and I ended up studying classical guitar and orchestral conducting. My first degree is a Bachelor of Fine Arts in Music Performance, for example. And I think it helped me be very aware of my, shall we say, my right brain, because engineering can be a very left-brained activity.
Correct.
So I think it's really good to kind of try to utilize both hemispheres. But after school, I tried to make a go as a singer-songwriter in the New York City area, both with bands and solo. But at 26, having dated the love of my life, met her 5 years earlier, I decided I wanted to get married, raise a family. Okay. And the type of person I am, I couldn't subject my wife and kids to the uncertainties. I'm sure that's a word that we'll get back to the uncertainties of the life of a musician, And so I said to her, Liz, I said, look, I'm going to change careers. I'm going to go back to school, and I'm going to go school full-time because I want to get this done. I'm already out living on my own, so I got to work full-time also. And I said, we're never going to see each other unless we live together. And your Catholic mother's never going to let us live together unless we're married. Yeah. So I guess this is my marriage proposal. And, not particularly romantic, maybe, sort of like an engineer's proposal, right? But it worked. She said yes, and next Tuesday we will have been happily married for 30 years.
Wow, that's awesome.
Yeah. So, so newly married with a first child on the way. I started out in the architecture program because that's what I thought I wanted to be at City College of New York. And while my classmates were talking about how the light comes cascading down the stairwell, I was looking and saying, so how are we going to build the structure across this span? And how are they going to build that? And my God, what's that going to cost, right? So it took me about a half a semester to realize I was actually an engineer, not an architect. But in my last year at City College, they were rededicating the David Steinman Center, and I was manning the ASCE student chapter, concrete canoe booth. And along comes one of City College's illustrious alum, Stan Merjan, who was a pile driving legend, just passed away last year, my first mentor in the business. And he's an original founding member of the DFI, and that's a great story for another day, the Deep Foundation Institute.
Yeah.
And after about 5 minutes, he said, you should come to my office on Monday morning. By Tuesday, I had a job offer, and by Wednesday, I accepted, and that's it. And it wasn't without trepidation, to the point of your podcast. It wasn't without trepidation that I sat there going, what's it going to be like to work for a pile driving contractor? Did I study all this, differential equations and linear algebra and fluid dynamics to just beat steel into the ground? And I very quickly learned just how fascinating it is to try to marry structure to the earth.
Wow. Well said. Well said. I mean, when you think about geotechnical engineering and you think about what it means to be an engineer, I mean, what comes to mind to you?
Well, so I was listening to this podcast, in fact, back in 2018. And they were interviewing the author of an article in New York Magazine. And I believe the title of the article is How Much of the Internet is Fake? It turns out a lot, actually. That's the full title. And in the interview, he says to the interviewer, he says, well, you know what fake ads are, right? And you know what bots are, right? And he goes, well, how many bots are clicking on fake ads, right? And and I remember thinking, and again, being who I am, I think to myself, oh, thank God I'm a civil engineer. Because the truth is, Jared, people will always need a place to live.
Yeah.
They will always need a place to work. They will always need a place to get from one to the other. And I like to say that when they get there, they're going to want electricity, running water, and HVAC. So I think our jobs are safe, for now.
That's fair. That's fair.
No matter how much technology there is. But I seriously, I really think civil engineers should be really proud of their very concrete contribution to the edifice of our society, and the built environment. It's really something to be, we're honored to be part of it. Leave it behind when we go, right? And it has a very real impact on the quality of people's lives.
Definitely. And I know that I mean a lot to our listeners. Some of them are in school now, they might be between geotechnical and structural or civil, or some might be in grad school, working on a master's or a PhD. And the question is, why should I do this? And when you think about, you said earlier, uncertainty, ending up in geotechnical engineering, I think we have a little bit of uncertainty here, right? So how do you reconcile that?
Well, okay, so here's the first, my first suggestion for your future podcast. I've listened to your podcast, and you guys are always saying, send us your suggestions.
Yes.
So I always have this idea in my head that I want to write a paper, looking back, on my career, that says, is the factor of safety for a pile load test 2 or 2.000? So let me take you back to school again, right?
Yes, please.
And it's the first civil engineering class you take at City College, probably many places, is surveying, right? And it's offered at Monday morning at 8:00. And you know how college kids love Monday morning, 8:00 class, right?
They love it.
And the best part is it's taught by this George Popoulos, who was an Army vet, a real drill sergeant type of guy.
Yeah.
And he was with the Army Corps of Engineers, but he also served. He was a decorated World War II vet.
Wow.
And real hard-nosed guy. And he says, the very first thing he says to everybody is, put your books under your desk, take out a piece of paper and a pencil. We're going to have a quiz. So the only thing college kids love more than class at Monday morning at 8 o'clock is a pop quiz on Monday morning at 8 o'clock, right?
Yeah.
But here's what he asks. He says, in your own words, he said, describe the difference between precision and accuracy.
Wow.
And that lesson, you know, I then proceeded over the next, you know, the first 10 years of my career to perform hundreds. I don't know if I ever got into, you know, 4 digits of pile load tests, tieback testing, rock anchor testing, right? Lateral compression, tension,
yeah.
Hundreds and hundreds of tests. And I can't tell you how much that lesson about precision and accuracy stuck with me.
Wow.
So even when we talk about uncertainty, for example, right, we got to ask ourselves, like, what is it that we're uncertain about? Are we, you know, is it a question of accuracy or precision? I will say that I find engineers, by our nature, we can get very wound up with precision, being concerned about precision, when it's probably accuracy is more to the point of what we should be focused on. I don't know if I answered your question, but you know, uncertainty. Throughout my career, you know, here's another funny thing. When you asked me to like talk here, I did what any engineer would do, right? I listed all the jobs I've ever been on, you know, been involved with. And as I listed them and I said, you know, here's, okay, the big takeaway from this job is this, the big takeaway from that job is that. And I realized that, you know, really it was always about finding the driver of the situation, right? In other words, there's multiple factors in any project. And they're not all engineering related. There's interpersonal communication, including personalities, right? There's finance, there's schedule, there's logistics, space, politics, all kinds of things.
Yeah.
You know, and as engineers, you know, we have to be good technically, but we have to know that that's what we bring to the table. But we have to have an elevated awareness that it may not be the engineering that's the main hurdle to success on a given project, right? And so uncertainty means a lot of things. I talked about precision and accuracy, but it also means that there are aspects where we're pretty certain that we understand, you know, this is not a risk, right? I said to one of your colleagues the other day on a design build project, I said, well, is lateral load an issue on these piles? And I proceeded to get a lecture from a young engineer about how lateral load is important. And I said, of course, lateral load is important. Lateral capacity is important. What I mean is, do we have any doubt that the pile is going to pass the lateral load test? That's what I mean. Because if we don't have any doubt that the soils are going to support it laterally, then we can stop talking about it and we can move on to some, in this case, some very serious logistical concerns that had to do with, you know, third-party agencies that were going to prevent us from doing what we needed to do, right? Wow. So, you know, so uncertainty can be implied in a lot of ways, but whatever the jobs I looked at, I realized you had to understand the driver of the situation, but it typically went back to some sort of, when it's engineering, it typically always fell back to some first principle of engineering, like precision versus accuracy, right? Or stiffness rather than strength. Everybody's worried about strength, but this is not really a strength issue. This is a stiffness issue, right? Things like that. So I would always say that, you know, you have to understand where the uncertainty is stemming from.
That's awesome. That's awesome. And when you look at all your projects, I mean, do you see any, I don't know if you want to call it underlying threads or narratives that, you know, we can learn from,
you know, so my daughter, you know, now kids are grown. One's a computer engineer, one's an optical engineer, you know, and my daughter, the oldest, the one that was, you know, born my first year of school, you know, she's brilliant, and she's a triple threat because she's beautiful, funny, and brilliant. But I remember her growing up, and then she'd always want help with, you know, calculus in high school or physics or whatever. And I would always be saying to her, like, okay, so let's examine the problem. What is the problem statement? What is it that we're trying to predict here? You know, and she would say, I think the answer is C. Is it C? You know, and I'd be like, okay, but first we have to understand the thing. And she'd be like, no, you're right. It's not C, it's probably B, you know. She was impetuous, you know, she was young and she wanted to get to the answer. She went off to McGill University, studied physics. And in the first year, she would call and ask me for help with her homework. In her sophomore year, she called me and she presented this very complicated dynamics problem. And I look at it and I start in with my usual, well, we need to understand what it is we're trying to figure out here. And she goes, wait, I think I got it. And she never called me again for help. She blew past my understanding of many subject areas. But later she would come to me and she would say, the best thing you ever taught me was I need to understand what the problem is, right? I need to understand what, and another friend of mine, colleague, has a sign on his bathroom mirror. So every morning when he wakes up, goes into the bathroom, it says, are you asking the right questions? You know, so to me, these are all related. The thread is, what is the driver? You know, when a team is working on something and you hit that wall, the question is, what is the driver?
Yeah.
Is it engineering? If it's engineering, what are the first principles that apply? Maybe it's not engineering. Maybe it's schedule, finance, personality, you know, politics, whatever it is.
Yeah.
And so, you know, we're good at problem solving, but sometimes we can sort of almost look past the problem into the details and miss it. You know, I also like to say that, you know, you think about cliches and like there's always, for every cliche, there's some human being that actually uttered those words first, right?
Yeah.
So everybody's familiar with that guy can't see the forest for the trees, right?
Yeah.
I've come to, every time somebody says that's like, yeah, the first person who said those words just left a meeting with an engineer. Because we're our own worst enemies sometimes.
We really are.
Yeah. But we love what we do. And the truth is that, you know, our comfort zone is like, hand me a set of drawings, I turn on my laptop, I open up an Excel spreadsheet, and I start to organize the information. And for most human beings, that sounds like torture, right? But for us, we're like, we could get lost for hours doing it.
Exactly.
And so we bring a lot to the table. There's no doubt we bring a lot to the table, and we should be proud of that. But we should also know when to step out of our skin, if you will, and try to examine what's really driving the situation. And if you don't mind, I know I've had a tendency to ramble on, but you asked about, you know, what's the thread? And so the other thing is, and you hear this expression all the time about thinking outside the box, right? So when you step outside your own skin, you know, usually for any problem, there's a sort of a consensus approach, like, well, this would be the normal thing to do, right? And then you run into those people that like to say, well, what if we did something different, right? And I like to think I've made a career out of being that guy in the room that's like, well, slow down. What if we do this, right? So the herd is running east. What happens if we run west?
Yeah.
And to be the best, some of the best projects I've ever been on, the best opportunities came when you could understand the driver of the situation, right? What the main hurdle was going to be. And it turned out that by taking a contrary or outside the box approach, resolved that main issue. To me, that was opportunity, nice. Right? Because people aren't going to see it, and you're going to sort of, you know, take everybody by surprise because you're going to solve this problem that some people haven't even figured out is the problem yet, and you're going to solve it by doing something that's contrary to what most people would want to do.
Wow.
So.
Now, how do you do that if you're starting out in your career and, you know, how do you step outside of your comfort zone and be the one person that says, I think we should try it this way? How do you do that? You know, how do you practice that? How do you get good at that?
Well, you know, I don't know. That's a really good question. And, you know, it's really important, you know, I'm sure there's, you know, younger engineers listening. When somebody who works for me gets their PE license, I always tell them, look, I give them this lecture about the first thing you need to know is what you don't know, right? Mm-hmm. That might be the most important thing you'll ever know as a licensed professional engineer is what you don't know. Yeah. You have an oath, you know, a responsibility, an obligation not to pretend to know stuff you don't know. Yeah. But to answer your question, the key is to keep an open mind. And the key is to seek help and ask people, you know, who would know, who have more experience, what happens if we do this? And don't be afraid of saying, of them coming back and saying, that's a terrible idea. You know, it didn't cost anything.
Yeah.
Right. You know, engineers are the people that get a 95 on exam, and the only thing they want to talk about is the other 5 points that they didn't get. Right. All your friends were like going for a beer at the pub because they got a 90. Right. And you're like, wait, I got to go talk to the teacher first. I got to understand why I didn't get these other 5 points. Right. So, you know, that's, I think it's important for us to understand that about ourselves, you know, have that sort of perspective about who we are.
I appreciate that. And I'm sure the listeners will as well. In your bio that I read earlier, you talk about how, you know, you believe strongly that the contractor's design of, say, deep foundation elements or even supportive excavation systems has a great level of economy and a good level of quality control. Can you expand on that a little bit?
Yeah. So what I'm trying to say is that contractor design, you know, it figures that you would pick up on that comment, right? Because you being a consulting engineer for most of your career, me being a contractor, I like to think that, you know, and this is probably pertains to geotechnical engineering. It's one of the things that geotechs love about it the most, right? So we'll use piles as an example, right? A pile design, right? So they're geostructures, right? So they have to carry the load structurally, but they also have to transfer the load geotechnically, right? So everybody's seen a pile detail on a set of plans, but the question when you look at that is, how does that thing get in the ground, right? It's just a drawing of a pile. Presumably, if you run the numbers, it can carry the load that you're putting on top of it. But to a person who's responsible for installing that pile, I look at it and I go, okay, here are the borings, there's the pile. How do we get that pile in this ground, right? And so the means and methods, including the, you know, selection of equipment and tooling and things like that, has a tremendous impact on the performance, the final performance of the pile. And so you need an intimate knowledge of the local geology. You need to understand what the experience of the trade craft locally can do. How many times, you know, you're in this business, so you know we talk about the skill of the drill operator and how important that is, right? So if I guess what I've seen through the years is I've seen plenty of bad designs, but I've also seen very good geotechnical engineers sometimes, in my opinion, push the envelope too far and try to eke out every last bit of performance out of a supportive excavation system. And I think to myself, you know, you really should leave that sort of last 25% of optimal performance to the contractor to design. Because these things like equipment, trade, talent, experience, or whatever, local geology knowledge are going to come into play to squeeze out that last 25% of performance. And, you know, this is probably not like necessary to apply this principle to every design, you know, timber piles for a sewer or something. No, but you know, when the chips are on the table and people are scratching their heads, it's probably a good idea to let the contractor assume the risk for that last 25% of performance, right? And have a say in how we're going to do it. You know.
Makes sense. So that comes into play when, you know, we're putting together a specification and what type of tolerances are there, right? Are we building a spaceship to go to the moon, or are we, you know,
so
building supportive excavation to put a vault in, you know?
Exactly. And can it be done, right? It's easy it's easy to cut and paste a line from a spec from another job when when you're a consulting engineer and time is of the essence and you've got a million things to do and it's midnight, you know, and you have an 8 a.m. meeting the next day. But the contractor lives and dies by that line that you just cut and pasted, right? And that tolerance may not be achievable under the conditions. I have numerous jobs in my head, you know, right as we speak, we have a job doing 500 caissons for the new South Yard assembly building at Electric Boat, where they're going to build the next round of, in 5 years, they'll start assembling Columbia-class nuclear submarines. Those caissons are 4 foot in diameter, right? 120 feet deep. Most of them are out on the water, in sloping granite, drilling through cobbles and boulders to get to the sloping granite rock. Meanwhile, right here in Manhattan, I'm involved in a project with 500 caissons also, but these are 13-inch in diameter, and they have to be installed in 12 foot of headroom, right? For a new 1,400 foot tall JP Morgan Chase headquarters.
Okay.
So there's funny parallels there, right? But it's one thing to write a spec, it's another to understand what's actually physically possible. And on both jobs, we have some of the best talent in North America working on it, and we're struggling to meet the tolerances that the designer thinks are critical.
Wow. It's good, good things to think about here. And the reality is that, sometimes these things make sense and are warranted, and sometimes they might not be. So things to consider. Definitely things to consider.
That's true. They don't, all the stuff we're talking about doesn't always apply. It's knowing when and where to apply it, right? And that comes with experience, right? So for your younger listeners, let it breathe, let it come to you, right? Like the athletes say, when you're at bat in the 9th inning with the winning run on base, just maybe try to breathe and let the game come to you a little bit, right?
That's fair. That often comes into play, especially when, I definitely resonate with what you're saying. As a geotechnical engineer, we design things, and one could say that it's wished into place, but how does it get actually in the ground? And oftentimes when we get out to the field and we're seeing things go in, that first instance, you have sloping ground, you have, deposits that have boulders and cobbles. Everything about that site wants this thing to not be vertical, right? Exactly. And so if you do have something that's out of tolerance, is it zero capacity? It's got to be better than what was there before. How do you resolve that, and how do we move forward? Exactly. Do I just outright reject it? You wouldn't want to hear that, but no. I might say that's the easiest thing to do. But, how can we get to a point where, everybody's moving forward, we're safe, and we're moving in the right direction? So
right. And the responsible contractors want to hand over a product that's going to, hold that building up for 100 years or more, right?
Mm-hmm.
We don't want to be associated with something that doesn't work. And that goes back to the point, you can, if, this idea of squeezing the last 25% of performance out and allowing the contractor to have a say in the design for that. Mm-hmm. Of course, it depends on the contractor, of course, and so on.
Got it. When you look back at your career, and you've worked on a number of different types of projects, can you think of a project that kind of stood out as maybe it was an integral moment in your career development, or something you're most proudest of? I mean,
you develop a sort of deep love affair with every project that you work on, right? It's love hate sometimes. But when I was looking through that list of projects, I thought, here's a project that I think touches on a lot of the things that we're talking about, right? So it was a job, for Langen Engineering. In fact, your colleague Saul Shapiro was the lead geotech on the job. It was the Kimmel Pavilion for the NYU Langone Medical Center in Midtown Manhattan. Mm-hmm. It was a job with one of the things we're doing, Ganu said the other day, right? So like we're always pushing the envelope of everything we do. Every, decade after decade, we keep expanding our horizons and our eyes and our appetite for challenge, especially in the geotech world. Yeah. So one of the things, about this job is it's on a site where nobody would have ever dreamed of building anything, 50 years ago. But, as the real estate values beckon, we just, is it possible? Somebody asks if it's possible, and the next thing you know, we're doing it, right? Sort of the human nature. But so it's this site where the Amtrak tubes, what are called the East River tunnels, bring Amtrak, but also notoriously Long Island Railroad, the biggest, heaviest, the largest commuter railroad in North America, comes into Manhattan from Long Island. And they're 100+ years old, so they're literally over their design life.
Wow.
And there are serious concerns about the conditions. We are in the footprint of what was the East River. years ago.
Hmm.
And across the site are several historic bulkheads that were constructed as the shoreline of Manhattan expanded. And the way they used to do that was they would build a timber crib, fill it with shot rock from construction, the subway, whatever, and it would just sink until it stopped sinking, and that's how you load tested it and knew that it was good, right? And then you built another one and another one and another one. So basically, we have to drill these piles, 112, as I recall, caissons, 36-inch in diameter, upwards of 8,000 kit capacity, allowable capacity, a brand new city building code, which was like right up Saul's alley because he's on the International Code Committee.
Yeah.
That's an interesting topic for a podcast. How there's only one geotech on the International Code Committee and 20 structural engineers. Maybe you can...
Thankfully it's Saul, right?
Exactly. We have a good champion there. And so what was cool about this job, or many cool things, but one thing they wanted to do is they couldn't obviously build on top of these 4 tunnels. So they built, literally, we built all the caissons between and around the tunnels. They brought the superstructure up several stories. And then I believe in the 6th, 7th, and 8th floors, integrated into the superstructure were trusses that would span over the tunnels. And then they would hang the first 5 floors on those trusses, right? And this is all fill, if you remember, over the river, right? So it's seismic active zone, infrastructure, the tunnels, right? And in the midst of all of this, just as the design is 90% complete, Superstorm Sandy, and FEMA decides we got to raise the floodplain 10 feet, right? Again, thank God it was Saul's job, right?
Yeah, right.
Who better to handle these challenges?
Wow.
And that, that's a lot, right? But my favorite thing about the job is this. Saul puts it out there, and he basically had discussions with Amtrak to say that, they really don't want us to drill with down the hole hammers, pneumatic drilling, for those listeners who know. And because of the age of the tunnels, because they're beyond the design life, right? So Saul does this very, very in-depth geotech report and study of the soils. And he determines that, I think we can drill this without air. We can use conventional tools. And in New York City, everybody's telling him, you can't do it. You can't do it, right? And so I delve into the geotech and the geology, right? And I'm imagining the geologic processes that he's talking about, right? And it involves this thing, if people are interested, Cameron's Line, right? Which runs all the way to the edge of the proto-North American continent, back before the continents, shifted to what we see today. And it turned that Manhattan schist bedrock on its ear, literally. And so this rock that I've held in my hands so many times, drilling piles, and rubbed it between my fingers, the mica and the feldspar and and I'm thinking about the way it's foliated and the way it's created in the metamorphic process, where gravity aligns all of the foliations and all of the minerals. And I'm thinking, what happens when you turn that stuff sideways after it's already made?
Wow.
And I think about the weathering process and all of these things, and how, it turned what were, they could drive the NX core barrels for the soil sampling, drive it with a standard hammer, and they're getting SPT values for standard penetration tests, blow counts, when they should be, when normally you couldn't do that.
Yeah.
And so I ended up working for the only contractor that agreed you could drill this stuff. I'm like, Saul's right. You can drill this without air tools. And I'm normally the guy I'm known for pushing the envelope on, we're going to drill with air. I know they don't want us to, but we're going to do it anyway, because there's no other way to do it. And all my competitors decided that, it couldn't be done. And we agreed to do it. And we got it done, and it worked out beautifully. And so it kind of sums up all of those things, right? Yeah. So it's what's exciting about geotech that makes it different from other branches of structural engineering. The idea that you're literally playing in the dirt. You have the rock in your hands. You're crumbling the cuttings between your hands and your fingers. You are studying the geologic processes from millions of years ago to see whether that can give you insight into the selection of equipment and tooling, right? And again, to hit on some of the things I said, when everybody was running east, the solution, the big driver for success was somebody was willing to go, no, I think the answers actually go the other direction. And, I credit Saul with having that vision. And so, so that's one job. And I mean, I could talk about probably every job I did, with that way, but, obviously we don't have years to talk.
That's awesome. That's awesome. What do you think, if you were to, come across a geotechnical engineer that's listening today and they say, wow, I would like to be a specialty contractor and I want to have a fruitful career. What are some of the advice that you would give them? Yeah.
So I think I said this earlier. I think that it's really important for engineers to have a good general understanding of the general sort of engineering personality, right? We're generally all good at math, right? We're generally all comfortable doing math all day long, right? We're generally disciplined about, our work ethic and stuff like that. We're conscientious. I mentioned that, like getting a 95 on an exam, we want to know why we didn't get 100. The biggest problem I have with the young engineers who work for me is when I give them an assignment, they don't want to come back to me until it's perfect. And I have to tell them, like, you see this red pen? I'm going to mark it up no matter what you bring to me. So the sooner you bring it to me and the sooner I get out my red pen, the less time the sooner we're going to get to the final product.
That's awesome.
So, and it's not a negative thing. That's not meant to be a negative thing. It's that, we sometimes as engineers, we avoid the collaboration aspect, of especially when we feel insecure that we don't have all the answers and we're supposed to have all the answers because I just got this degree in engineering, you know what I mean? Yeah. And when you just have your degree in engineering, I know you went and got right back, you went and got your master's at Illinois, right? I mean, one of the top schools in the country. And what they do, they sent you out the field to go figure out like how little you actually know about how this is done. Right?
Exactly.
Put you in your place and go, okay, kid,
Yeah. School of hard knocks.
Yeah, and I think that engineers could, there's probably some tools you can do to reach out, and maybe even podcasts like this are useful for that, right? To remind ourselves, look, we're just human beings. We have our own set of personality traits. We bring a lot to the table, but we could learn to be a little more open, more collaborative, more willing to show what we don't know, as well as show what we know.
Excellent. Well, that's a good point. Right now, we're going to take a pause for a quick moment, and then we're going to close this one out with Andy and our career factor safety in segment. Stick around. All right, welcome back, everyone. It's time for our career factor of safety in segment. In geotechnical engineering, like many disciplines of engineering, it's important to incorporate a factor of safety into your design. And our guest for today talked about that earlier. But what about incorporating a factor of safety into your actual career? Today, of course, we're talking with none other than Andy Burns. Andy, I look at you and you've told us a lot about what you've done career-wise, but I think that you've really built learning and development skills into your career. And I think that it gave you a factor of safety so that you could be successful. So for our listeners, what's the best way for them to stay up to date with technical trends in the field?
Yeah. And it's funny because it's a really good question. And there's a couple of thoughts that pop into my head. One is just the irony of geotech itself, right? The engineering material we're dealing with is as old as dirt, literally. It's the equipment, a lot of the processes we do. I love Ralph Peck quote that says, pile driving is a crude and brutal process. He goes on to say that, sophisticated discussions about soil pile interaction are often out of touch with reality. And then I'm only going on because I know of your connection, right, with Peck, and he says there will be problems, period, right? So not there may be problems, or you're going to face challenges. He just says, his sentence is, there will be problems, period. Okay. So and then so that's sort of like some of the delicious irony, if you will, about geotech engineering, is that it's very technological at the same time. We're constantly tweaking and changing what we do. We're constantly developing new equipment and new processes, right? The equipment's constantly destroying itself, trying to like beat steel and get concrete and steel into the ground, into this billion-year-old rock. And one of my colleagues says, it took, when people are struggling on a drilling job, he says, it took 4 billion years to get that rock there, and you think you're just going to remove it, in an hour or two. So that's sort of an irony about geotech, right? And then the other thing that popped into my head is you guys do this segment and you use the word factor of safety, right? So, and factors of safety, as we talked about, are designed, it's a mechanism to deal with uncertainty, right? So I talked a little bit about what is it that's uncertain, right? So to your point about what should young engineers do, it's really, I guess what I was trying to say is it's vital to remain on top of the developments, because you just don't know where the big successes are going to come from. Right. And so probably the best way to do that, in my experience, has been for young engineers to be active participants in the trade organizations that we have, right? So everybody knows ASCE.
Mm-hmm.
We talked about the Deep Foundation Institute, or DFI. There are others like ADSC for drilling contractors, the PDCA for pile driving contractors. And when I talk to young people, and some of them are they're just getting their career off the ground, and maybe they have romantic relationships and they're getting married, or they're having kids, right? The question is, where does the time come from to go join some, attend a conference, for example, right? So I always get asked, so what is the benefit of doing that? And I say, yeah, it's a really good question. And I really struggle is even though I'm convinced that it's the right thing to do, I struggle to how to articulate it.
Okay.
But what I can tell you is that when I look around at the industry, the people that are most fulfilled in their careers, right, are the movers and shakers, if you will, the people that are impacting the industry, are the ones at the conferences, right? And I think that it's not just attending a seminar, and listening to people speak about, passionately about the work that they love, and the technical developments, but in the bigger picture, I think it's actually about realizing that you're part of something bigger than just yourself.
Wow.
And realizing that, when you hit that wall, at midnight trying to solve a problem, and you will hit that wall, that there's other people out there who are trying to solve similar problems.
Yeah.
Right? It's that we're all in it together type of thing. And through the years of doing that and participating and throwing your own stuff out there, the jobs that you're passionate about, right? You meet the other like-minded people.
Yeah.
And then the benefit is that years later, you have this network of people that you can go to the next time you hit that wall.
That's awesome.
Yeah. So I would strongly encourage people, tough in the COVID era right now because all of the conferences are being turned to virtual ones, but it's important that you interact on a personal level about your profession, including both the technical and the non-technical.
Yeah, it definitely helps with awareness as well.
Yeah, because you're going to be you're going to make a friend, and that friend, you're going to tell that friend that you're working on this job, and he's going to say, "Oh, hey, did did you ever see this piece of equipment? Or did you see what they did over there on California, right?
Yeah.
And next thing you know, that might be the solution to your problem.
Yep, you're absolutely right. You're absolutely right.
So, if you stick your head in the sand, that's just you're doomed.
Excellent. Andy, thank you so much for coming on, and thank you for sharing all the insights you did. And thank you for what you do as an engineer. Appreciate your contributions. And you shared a lot with the listeners. I'm sure they're going to appreciate the advice that you share. And if somebody wanted to get in contact with you, what's the best way to find you? Your social media or email?
Yeah, I'm very old fashioned. I'm not on social media at all.
Okay.
So it's just my email address is andrew.burns, that's BURNS, at Skanska.com, SKAN as in Nancy, SKA.com. Shoot me an email anytime. Always willing to make time to talk.
Excellent. Thank you so much for coming on. Really appreciate it.
Thank you, Jared.
I hope you enjoyed our episode today. We would love to hear your feedback, comments, and/or questions. Please feel free to go to geotechnicalengineeringpodcast.com, where you'll find a summary of the key points discussed in today's episode 11, as well as links to any of the resources, websites, or books mentioned during this episode. Until next time, we wish you the best in all your geotechnical endeavors. Peace.